Okay, so picking up where we left off yesterday at number 3, doing a little bit more division. The note here, however, let me see if I can get that a little brighter. There we go. Okay, so I want to look at our note. It says to insert 0x as a placeholder in the dividend. Remember, we had to put them in order? That was one of the things, was to make sure that our exponents were in descending order. So this is, we have 3x cubed minus 8x squared plus 0x, because we don't have anything with just one x, and then plus 14. It does do something. When we go to division, it does do something. They have to be in descending order. It does descend, and we have to have every place. So you might have to put in a 0x squared and a 0x, or you might have to put in a 0x squared and a 0 for a constant. There has to be a placeholder in every number, right? Just like when you do multiplication, right? We do 14 times 26. We do 6 times 4, and we get 24, and 6 times 1 plus 2, and then we put a placeholder. Right? That placeholder is important. It has a value because it's holding a place. Okay, so these are things that we've learned when we're younger, like we have to have a placeholder. It's the same here. We have to hold the place of whatever term is missing. Okay, so we have to do that same thing. All right, so determine whether x minus 2 is a factor. So that's a little bit different, but that's still division. We want to know if it's a factor. Factors are, right, when you multiply two numbers together. So 14 is a factor and 26 is a factor to whatever our product is. So we want to know if I can multiply this by some other number to get this one. So we do the opposite. We do division to find out. So 3x cubed minus 8x squared plus 0x plus 14 divided by x minus 2. Yeah, that's tricky. All right. So how many times will what will x need to be multiplied by to get 3x cubed? So to get the 3x squared. Beautiful. Okay, so that's going to give us 3x squared. And then what's 3x squared times negative 2? Thank you. 3x cubed on the bottom. So it's 3x squared times negative 2. Sorry. Negative 6x squared. Beautiful. And we're subtracting all of that because we subtract in division. That's how we do long division, is we subtract. Okay, so 3x cubed minus 3x cubed cancels. Negative 8x minus negative 6x squared. Ooh, that one would be negative 2x squared because we are adding. Okay, right, because minus and negative is the same thing as addition. So this is a negative 2x squared.
Do you bring both the 0x and the 14 at the
Nope.
same time?
You just bring the 0x, so plus 0x. Just bring the 1 down like standard division. At some point you may need more than 1, but you shouldn't. Okay, so next up, then, how many times what do we need to multiply x by to get a negative 2x squared? Negative 2x, okay. So negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive, right? Negative times a negative is a positive 4x. All right, and I'm going to subtract this quantity. So negative 2x minus negative 2x cancels. 0 minus 4x is negative 4x. Drop the 14 down. So plus 14. Okay. I'm going to switch up my color here because I'm going to get to the black. Make sure you guys can see it. All right, so now, what do I multiply x by to get negative 4x? negative 4. So the yellow is kind of hard to see there. I apologize, but it's going to be okay on the black. So negative 4 times x is negative 4x. Negative 4 times negative 2, positive 8. All right, and I'm going to subtract this quantity. So negative 4x minus, let's see, what else can I do? So negative 4x minus negative 4x cancels. 14 minus 8. 6. So we have a remainder this time. So this is remainder 6. So is this a factor? No. Why not? X minus 2 is not a factor because there's a remainder. Good. Because there is a remainder. So yep, x minus 2 is definitely not a factor. Very nice. Okay, are you ready for the shortcut called synthetic division? It's a beast. It's not a calculator. It's way better than a calculator, man. Okay, so your sheet, does your sheet look like this or does it look different? It does? Okay, so I reprinted them. I couldn't remember because I made some adjustments. Sorry, there's a glare on the board today from the light and I can't seem to, it's a little weird. Okay, so synthetic division is a simpler algorithm that can be used to divide a polynomial in the form of x minus a. Okay, I want you to highlight, circle that, whatever. It can only be used if it has that binomial. Okay, if it has a trinomial, we can't use it. They were doing construction work downstairs and my board and stuff was not working. I will have to give those to you personally. Okay, so yeah, go ahead and do 8 too, and then I can do those. Okay, so this will only work when we have the short, like not just, I mean, it can be x plus a as well, like x plus 3 or something, and we would use a negative number, but it has to be a binomial. All right, so synthetic division is the same process as long division, except it eliminates the repeating writing of the variables and uses just a from x minus a. So if we look at this, this is the long division, and this other one is the synthetic division. Okay, so let's see how they are like the same.
Funny that the synthetic is the shortcut, but it looks like it takes up more space.
It actually doesn't. So they're giving you this, in this example, giving you step by step of what's happening. It actually will take up less space because you will only have this really in the end. Okay, so I understand what you're saying, but so what this is saying is like here's our long division. Here's synthetic division. Where did these numbers 3, negative 8, 0, and 14 come from? The original problem, right? In that descending order. There's the 3, the negative 8, the 0, and the 14. Slash, this is just the problem we solved on the front. Okay? All right. So this, where'd this 2 come from right here?
That's the x minus 2.
That's the x minus 2. Okay, so it came over there. All right, so we brought down the 3 and we write it. Okay, that's the first step in synthetic division. But then the next step, because it's showing you separately, is we have this 6 over here. Where did that 6 come from?
What is that we have to do to get negative?
Okay, the 6 comes from 2 times 3. 2 times 3 is 6. So then negative 8 plus 6 is negative 2. This is addition in here.
A positive 2 because the formula shows that there's already a negative in there?
Yes, this formula, like this is the formula, x minus a. So if it's x minus, then you just put the, and if it's a x plus, then you would put a negative number in there. Yep.
It's the same confusing stuff as H.
Yeah, kind of h and k.
So
So we do 2 times 3 is 6. And then the cool thing is that we're doing addition. We're not having to deal with the minus and negative and minus a positive and all that stuff. Like this is straight up addition. So negative 2 plus 6, or negative 8, I'm sorry, plus 6 is negative 2. And then we do the next one. We take 2 times negative 2, and we write negative 4 in the next column. It's addition. 0 plus negative 4 is negative 4. Then we do 2 times negative 4. We put that number up here. It's negative 8. 14 plus negative 8 is 6. That's our remainder, just like we had it. Huh? Well, that's when you write the variables back. The variables don't change. One thing we haven't talked about is if you look at this, when we did this, your variable, like if we look at our answer here, we started with x to the power of 3. Our answer started with x squared. That happens every single time. It drops down one exponent for our answer. So when we started with x cubed, when we get these numbers, 3, negative 2, negative 4, and 6, we write them. 3 started with x cubed, so my answer is going to start with x squared. Minus 2x minus 4. I've done all the descending order. I got to my constant. The next number has to be a remainder. Every single time.
So that's how you know if you have a remainder or not, depending on what your exponent is.
Yep. Yep. It depends on what your exponent starts with. So let's actually try them. Okay, let's do those examples on example 4 and see what we get. Okay, so we're going to use the synthetic division to divide. All right, so first up, list the coefficients in descending degree, including a 0. Well, we have an x squared, so we have a power of 2, a power of 1, and a constant. That's perfect. Okay, we don't have to do anything. What's the coefficient for this one, though? What number? 1. Okay, that's going to be helpful. So we're going to have 1, negative 4, positive 2. And what are we dividing by? 2, because remember this is supposed to be in the form of x. There is no 0 in this one.
It goes x squared, x.
Oh,
Because we have them all. Yeah. Okay.
I forgot that's why we did that.
That's okay. All right. So this is in that form x minus a, so our a value is a positive 2. All right. I like to draw my arrow, so I have room, and then I draw my line, and we're ready to start. The arrow means what?
Bring it down.
Bring it down. Okay. And now I start with multiplication. So this is my original setup. Right. So 2 times 1 is 2. So I put that here. And I'm going to remember, I'm doing addition. What's negative 4 plus 2? Negative 2.
And 2 times negative 2.
So now I'm going to do 2 times negative 2 is negative 4. So what's 2 plus negative 4? Negative 2. I'm done with the math.
It's going to be 1x.
Okay, so yeah, so just a second. That's okay. Okay, so we started with an x squared. So we're going to start here with just an x. So we're going to have 1x, if you want to write it, minus 2. That's my constant. So this is a remainder.
Negative 2?
Yep.
You have a remainder of negative 2?
Yep, absolutely. What happened with what? The x with the squared? Because every time we do division, we're losing, essentially we're losing a place value. Right? This is a place, like we had the placeholder, so we're losing the exponent with a power of 2. And we only now have an exponent with a power of 1. I can't get rid of what x? I used the formula. This is a system that helps. I didn't get rid of it. This is saying that this quantity, x minus 2, remainder negative 2, if I multiply that by x minus 2, I would get this back. But it's not a factor because it has a remainder. We don't know what to do with the remainder thing. Okay, I still what? No, just like in regular division, if we took 3.
If you're going down with the exponent, then yes, it would be an x, but you don't get rid of the x. It'd just be 4x to the 0, but you can't have that. It'd just be 0. So why is it 2?
Okay, where are you talking about? Where is it 2?
Right here. Because you're starting out with x, and then you drop that, and it's x, and then you're starting out with 4x. There should be an x here somewhere.
No, because, okay, that's what I'm getting at. Like here, 325, we are like divided by 15. We did a 320 earlier. Okay, we have 3 digits, right? 3 values. So we do the division. Okay, we say it doesn't go into the 3. 15 won't go into 3. So we don't put anything there. We lose that place value. If my pen would work. Awesome. So we lose that place value, okay? And then we say, okay, we'll go into 32 twice, and we get 30, and we have 2, and then we bring down the 5. And so 15 goes into 25 once, okay? And so we have 15, and then we have 10, a remainder 10. It's the same thing. X minus 2 won't go into this place value, so we shift it over. We went from a 3-digit to a 2-digit answer.
So how do you know what you're getting rid of then?
You always get rid of the first one. Like this started with x squared. This one starting with a cubed. Your answer will start with a squared. You will lose that a to the power of 3 in doing it. It always drops 1 power.
Take an x or an a or whatever from each one.
Everything with a variable in your
Will
problem
go down by 1
answer
power.
will go down by 1.
Yeah, the answer will always go down by 1 power.
Even if that means, like you said, losing an x.
Yeah. So if you feel like you're losing it, it's totally fair. It's okay to lose it. All right, so let's look at the next one. We have an a cubed, an a squared, an a, and then a constant. Are we set?
There again.
They're all there. Okay, so then to do our synthetic division, we're going to have 5,
Plus 4 minus 7.
4, negative 7, and 9. Okay.
And
But it's
negative
the negative 2 to divide by.
All right, so this time, right, this is our formula is x minus a. So in this case, or that's confusing to people. All right, but we have to use a negative 2 since this is a positive 2. All right, we bring down the 5. And that's our setup. Then we're ready to start doing the math. Okay, so negative 2 times 5 is negative 10. 4 plus negative 10 is, all right, Brandon, negative 2 times negative 6. 12. So it's negative 7 plus 12. I think I heard somebody say it. 5, okay. All right. Ethan, what's negative 2 times 5? Negative 10. And 9 plus negative 10? Negative 1. All right, so when we write our answer, we started with a cubed, so now our answer is going to be a squared. So 5a squared minus 6a plus 5. Oh man, we're all the way down to the constant, so we have remainder of negative 1. You will not always have a remainder. Okay, but I want you to see, like, it is okay. Like, you are going to have remainders, and that's just telling you it's not like you've done the work, but this is not, right? This is not a factor because there's a remainder. This one is not a factor. What was that?
So it looks like you drew a flag with that thing around the x minus 2 and the r's.
Oh, okay.
The way it's like curvy.
Yeah, down there.
Gotcha.
Not up there yet.
Up here.
Down there.
Looks like a flag. Okay, gotcha. All right. So then let's try example 5. Or actually, let's have you guys try that one on your own.